than CAN. Okay, so we use tools like Hadoop, Scoop, and Flume for our analytics, and we use again the columnar storage of Vertica as our data warehouse. Okay, that's a brief introduction of myself. Okay, let's start with the demo of today's session. I'll be dealing with, let me give a brief introduction of how I build my demo right now. I'll just take a 40 to 45 minutes to explain about the basic things of Hadoop, like what big data is and what is the definition of Hadoop. Okay, after that I'll be talking about what is a MapReduce and what is a distributed file system, and then I'll be talking about evolution of Hadoop. After that I would say where are we receiving data from. Okay, this is how I'll drive my session for the next 40 to 45 minutes. Yeah. So, what is big data? Many of you have heard of this particular term, big data, when you are listening to the term called Hadoop, right? So, big data is nothing but the collection of larger data sets which is difficult to be stored or analyzed in RDBMS. Okay, when I say it's difficult to be stored or analyzed in RDBMS, there should be some valid reasons why we are not able to store or analyze our data in RDBMS. Okay, the first reason for not being able to store large data sets into RDBMS is simple. Let's say if you take some social networking sites like Facebook. Okay, Facebook is providing almost like 15 terabytes of data. Okay, and if we talk about New York Stock Exchange, which is again producing almost like 11 terabytes of data. Okay, when you store such large data sets into RDBMS, you will be ending with no physical space. If you directly go and store the data into RDBMS, you will not have a physical space to add extra hard disk. That's the situation. Okay, and even if you have feasibilities to store your larger data sets into RDBMS, how do you analyze that? Okay, let's say that there are some 1 billion records of an employee table. You wanted to retrieve 10 records out of 1 billion records. Okay, when you wanted to retrieve 10 records out of 1 billion records, you got to stream across all the 10 billion records, right? So when you are doing that in RDBMS, there will be a lot of constraints like integrity constraints like primary key, foreign key, and if you wanted to join, then there are some conditions which prompt you to join with other tables, and this join also degrades your performance. And if you wanted to select 10 records out of 10 billion records, it will take ages to get your output, right? So what is the alternative for that? How would we arrive at a solution to store and analyze these larger data sets? Yes, of course, there are many other tools like Cassandra, MongoDB, Vertica, all these are there. But what is the one which we are going to discuss is Hadoop. Why Hadoop is being preferred than other technologies like MongoDB, Cassandra, everything is simple. We'll get to know this particular question and the answer for this particular question when I discuss about the definition of Hadoop. Right. So I'm just giving a heads up of what big data is and what Hadoop is and what evaluation of Hadoop is. If you have any questions, you can stop me and you can ask your questions right away. Okay. Let's go to the definition of Hadoop. Yeah. I would say Hadoop is the best fit to store and analyze our larger data sets because it has been technically and analytically proven. So what is Hadoop? Hadoop is a framework that is built on Java, which is used to analyze larger data sets using the file system called Hadoop Distributed File System and a programming model called MapReduce. Okay, I'm repeating. Hadoop is a framework that is written in Java to analyze larger data sets using a file system called Hadoop Distributed File System and a programming model called MapReduce. So I'm sure most of you might have heard HDFS, which is Hadoop Distributed File System, and the word MapReduce, which is we call it as MR. Okay, so what could be the definition of Hadoop Distributed File System? Okay, let me explain in a layman language. To arrive at what HDFS is, let's take a general example. Let me quote like I have some 100 bricks that has to be taken from one place to another place. That's my client's requirement. He has asked me to put these 100 bricks from one place to another place. For that, I have recruited one person called ABC. This particular ABC can lift one brick. I mean, he can put one brick in 1 minute. But my client has given me a very stipulated time frame, which is 10 minutes. In this 10 minutes, all this 100 bricks has to be put into another place. But I have only one person who can complete this in only 100 minutes. That's his maximum achievement. Okay, he cannot complete that in 10 minutes. So the option I have is I'll recruit 9 more people who are similar to the capability of ABC. Okay, so each one will be lifting the brick and putting the brick into the destination in 1 minute. So it's like, and I split the work among all these 10 people. All these 10 people would be completing the work in 10-minute time frame, right? I'll be allocating 10 bricks to each people so that all these 10 people would be putting the bricks in 10 minutes. So the funda I'm using over here is I'm splitting the work among different people and I'm making them to work in a parallel manner. Okay, that's the funda I'm using. Okay, so when I have 10 people, when I'm distributing the work among 10 people, that's where your Hadoop distributed file system comes into picture. It works in a manner of distribution. It distributes the work among different file systems. Okay, so apart from distributing the work among different file systems, it makes the work to be done in a parallel manner. So who does this parallel manner? Who invokes this parallel manner? I would say MapReduce is the one mechanism which we use to make the work done in a parallel manner. Because here now you can see that I have split the work among 10 people and I have made them to work in a parallel manner. Right? Who has split this? Right? And after the end of your work done, we got to combine the result and give it back to the client. Who combines this result? That's again another thing, right? So the splitting and combining the result has to be written by the developer. That means he will be developing the logic for splitting and combining your result depending upon the business logic. So that he'll achieve it using a programming model called MapReduce. Mapper is one paradigm, reducer is another paradigm. Mapper is basically used to split your work. Reducer is used to combine your result. Okay. So I'm repeating the definition of Hadoop once again. Hadoop is a framework that is built on Java, which is used to analyze larger data sets using a file system called Hadoop Distributed File System, which we call it as HDFS, and a programming model called MapReduce for parallel processing of your larger data sets. And this MapReduce we call it as MR. So any questions on this slide, please? Anyone? Okay. Fine. Okay. So I'll move on to my next topic. Now that you are aware of what Hadoop is, okay. Now let's look at the evaluation of Hadoop. Okay. Who is the founder of Hadoop or the creator of Hadoop? It's Doug-Cutting. D-O-U-Z-C-U-T-T-I-N-G. So how Hadoop had evolved? Doug-Cutting at around 2002 was working for a company called Apache. Okay, he is working on a project called Apache Lucene. Okay, Apache Lucene is the project in which they are developing a search engine called Nudge. Okay, you know, and a search engine like a Google or Yahoo or whatever search engine has, it has three parts basically. One is a mapper, one is a crawler, and another thing is indexer. Okay. Even this nudge has all these three components. They wanted to build a search engine which would index up to 1 billion pages. Okay, which would index up to 1 billion pages with an optimal cost. That's their architecture actually. So they had some initial architecture to implement on nudge at around 2004, sorry, at around 2002. But at the start of 2003, they had realized that their architecture is not scaling up to 1 billion pages to index. So whatever initial architecture which they have, it's not scaling up to 1 billion pages. So what they thought was like, they had to change their architecture. Okay. At the same time, Google has published its white paper called Google File System, which we call it as GFS. Right. So at the start of 2003, Google has published its white paper called Google File System, which Doc Cutting had implemented into the project Nudge. He has implemented this Google File System into this project Nudge. So they call it as Nudge Distributed File System by the end of 2003. Okay. Then again, at the start of 2004, Google has published its another white paper called MapReduce. Let me tell you, Google's architecture is based on big tables, and big tables is totally dependent on this Google File System and MR. Okay, that's the architecture they had published as white paper. So Doc Cutting had implemented that into again Nudge. Okay, by the end of 2006. So by the end of 2006, they have come up with a project called Nudge, which is a distributed file system, distributed search engine with a MapReduce architecture running at the background. Right. So that's the time Doc Cutting had left Apache and joined Yahoo. Okay, and Yahoo had provided him a dedicated team to work on again the open source project called Hadoop, which is almost similar to the Nudge. So I would say Hadoop has been born out of Nudge. Okay, because Nudge is a search engine, I agree, but it's based on distributed file system and MapReduce, and again Hadoop is also evolved with the same core funda, which is distributed file system and MapReduce, which we discussed earlier. By end of 2008, Yahoo had published its cluster of 900 and odd cluster, okay, which is built with distributed file system and MapReduce. That's how Yahoo had joined the race of big data and analysis of big data. Yeah. You can ping me if you have any questions on this slide. I'll wait for 1 minute. No questions? Okay. Okay. Now, you know the history of Hadoop, and you know what Hadoop is, right? And you know what big data is. Let's move on to our next slides. So I told big data is collection of larger data sets, right? When I say larger data sets, where are we getting all these larger data sets? These are the actual facts. So number of mails that are being sent for every second is 2.9 million. Okay, and the data consumed by the household each day is 375 megabytes, and video uploaded into YouTube for every minute are 24 hours, so 20 hours of video content. Okay, for every minute we are uploading that. Okay, data processed by Google per day is 24 petabytes, right? Feeds per day are 50 million. Like that, if you talk about all this New York Stock Exchange, eBay, Facebook, and United Health Groups, all the health organizations, how much of data they are producing, when you combine all these things, you end up with large amounts of data. That's where data is coming from. Data is coming from every organization. When you store something into your database, that's a data. When you share something in FB, if you update your status, that's a data. If you like someone's post, that's a data. Let me tell you, everyone's like, a single like will occupy 10 kilobytes of data in Facebook's database. Okay. So that's how your data is coming from. Data is coming from everywhere. So what parts of data we have? What are the types of data? Okay. And as I told, data is coming from everywhere, and data is coming in all shapes, size, and variety. Okay. When I say in all shapes, size, and variety, how do we classify that? Right. One is structured data. So let me quote an example for structured data. As everyone, almost everyone is aware, like structured data is nothing but the data that got stored in database. Okay. So let's say like we have a database. Okay. On top of database we'll have schemas. On top of schemas we'll have tables. On top of tables we'll have columns, and columns in which the data gets stored in sort of rows. Okay. That means your data is very much structured and hierarchical. Right. So when I point something to a normal RDBMS data, that will be a structured data. Right. What is the semi-structured data? When I say semi-structured, I'll quote an example of email. Okay. Let's say when you have some bunch of mails, looking at those bunch of mails on a high level, you can easily figure out who has sent that mail. Sure, Mohan. The question is to repeat the structured data once again. Let me do that. Okay. Structured is nothing but the data that got stored into RDBMS. Why I say the data in RDBMS is structured is we have a database, right? On top of database we'll have schemas, right? On top of schemas we'll have tables. Okay, each schema will have separate tables. On top of tables we'll have columns. Columns is the actual piece or actual field at which the data gets stored in the form of rows. That means when you observe this, tables, database, schema, tables, columns, and then the rows, everything is structured. You can point to any, if you want to query at a particular column, you can definitely do that because everything is in a structured manner. Okay, you cannot bifurcate one thing and you can go to other thing because everything is in a proper manner. That's the point of structured data is. Yeah. Are you clear with this, Mohan? Okay, great. And then let's move on to the next data type, semi-structured. Okay, semi-structured, I would say, like I said, I would quote the example of bunch of emails. Okay, let's say a situation where you have bunch of emails. Looking at those bunch of emails on a high level, you could say that where the data is, who is sending the mail, to whom they are sending the mail, right? Okay, but the actual content of the mail will be unpredictable. What is the different file system among which mappers fit the data? Yeah, I'll come back to your question, Vijay. Let me complete this types of data. So when you look at some bunch of emails, you'll know who has sent the mail, to whom they're sending the mail, okay? But the actual content is unpredictable. So when I'm quoting this emails example, only part of your thing is structured and the rest of the part is semi-structured. I mean, your rest of the part is unpredictable. That's why we call it as semi-structured. Only few things are structured and half of the things are unstructured. So that's the example for semi-structured data. Okay, and then there is another thing called unstructured, which is like if you look at some image file or an audio file or a video file. I mean, take that into your Unix server or somewhere. You take an image file into your Unix server, catch that image file. You will be getting some chunk values. because your audio, video, image files will be in binary format. So when you cat it or when you display it, you'll get an unstructured data. These are the examples for unstructured data: audio files, image files, video files. All this stuff are unstructured data. So of course, Hadoop can be used to analyze your unstructured data as well. During our session, we'll be looking at a case study where we'll be analyzing some image files. Okay. The case study would be simple. You'll have some 30 or 40 image files, okay, out of which the image files will be duplicated. Let's say out of 30 image files, I have some 10 image files that are duplicated. Okay, because consider a situation where you have some 10 billion image files or 1 billion image files, out of which you wanted to know, right? Out of which you wanted to know what are all the image files that got duplicated. You got to filter out the duplicate image files without opening or viewing the image files. Okay, that can be done using MapReduce, which we'll be looking in our course of session. How to analyze an image file, right? I mean, the funda is same. When you talk about image file, audio file, video file, everything is same. All these are binary files. So you got to convert them into some sequential file format and then run your MapReduce, and you have to look at your result. That's the thing. Okay. These are the types of data. So anyone has any questions on this particular slide? Okay. Yeah. Coming back to Vijay's question, what is the different file system among which mappers split the data? Okay. Vijay, I'll talk about how a distributed file system. To answer your question, let me go a little deep actually. Let me show an example, then you might understand it. Okay. I told that Hadoop has something called HDFS, which we call it as Hadoop Distributed File System. I'm just jumping back to this particular thing because to answer Vijay's question, I'll continue my slide after this explanation. Okay. Let me go back to the definition of Hadoop, what we have discussed. I had told Hadoop has something called Hadoop Distributed File System, which distributes the work among different file systems. Okay. Let's consider here there are different file systems. Like I would say, file system would be I will call them as node. Okay. So when you hear about Hadoop, you'll hear like something called the terminologies like nodes and clusters. Okay. A node is something like a system. For now, I'm just giving in a layman language. Like there will be different terminologies or the jargons we'll be using later on. For now, what I'll tell is a node is a normal system, okay, which is made up of commodity hardware. Okay, commodity hardware is nothing but the cheapest hardware available in the market. When you look at your production servers, you'll always look at some enterprise hardware. So what's the difference between enterprise hardware and commodity hardware is? Let's talk about a tool called Teradata, an IBM product, right? So when you look at some Teradata, when an organization ABC is using Teradata, for every quarter, Teradata, that particular organization ABC has to pay to IBM for using its product Teradata. Okay, and if there is any problem with the Teradata, IBM guys will be coming in and they will be sorting out the issues if they had some internal hardware issue or something, because they are paying for that. That's an enterprise hardware. Like I said, the nodes that are being used in Hadoop are systems that are made up of commodity hardware. So commodity hardware is the cheapest hardware available in the market. So when I say cheapest hardware, Okay, it's like an assembled systems which you talk in your real time. I mean, though it's not exactly similar to that. Commodity hardware, I would say, it's the cheapest hardware available in the market, and there will be no enterprise who, I mean, there will be no entrepreneur or the owner of a particular system who will be providing you the services. We are trying to get some cheapest hardware to build some nodes in Hadoop cluster. So when I am saying some cluster, let's go to that terminology. Before knowing what a cluster is, let me ask you, are you clear what a node is? Vijay, are you clear with what a node is and what sort of hardware it's made up of? Yes? No? Anyone? If you don't understand what a node is, you can type in your chat. Else, I'll assume that you are completely familiar with what a node is, and I'll proceed with the next explanation. Okay. Okay. As I told, node is a system in Hadoop which is made up of commodity hardware, right? So, group of these nodes, I would say, the group of nodes is called a rack. Okay, and group of racks is called a cluster. So that's where there's a rack, cluster terminology you will be hearing in Hadoop. Okay, group of racks is called cluster, and group of nodes is nothing but rack. And one rack can be located in Asia, and one can be located in North America, one can be located in South America. Okay, this is to ensure your business continuity. Okay, the racks will be, there are organizations where the racks are present in a single location. There are organizations who have some confidential or critical data. They will be having the racks in different locations for the purpose of the business continuity. So, as we discussed, a node is something which is made up of commodity hardware, and there are some group of nodes in Hadoop cluster. So, when you have some work to be done, what mapper does it? It splits the work among different nodes present in your cluster. Okay, when I say Hadoop distributed file system distributes the work among different file systems, it's nothing but the work is being split among different nodes that are being present in a cluster. Okay, this is how Hadoop achieves the parallelism in its work. Okay, so hope I had answered Vijay's question. If you have a query on this still, you can just type in again. So we had discussed about the structures of data like structured, semi-structured, and unstructured. Before that, let me just give a gist of what we have discussed what data is and what are the challenges we are facing in storing the big data in RDBMS, right? And then we had discussed what Hadoop is, and we have seen what a Hadoop distributed file system is and what MapReduce uses. Okay, and after that we had come up with the history of Hadoop, how Hadoop had evolved. Okay, and after that I had shown you a slide where from we are getting the data, and from that slide we understood that data is coming from everywhere. Okay, and we had discussed about the types of data like structured, semi-structured, unstructured. We had quoted an example for each of these types, right? And then this is a visual representation. Structured, like I said, you take it as a database. I'm showing you an example of Excel here. Even you can quote Excel as a structured data. Everything will be structured. You can point to any column of, any row of any column. Okay, that's why the structured feasibility comes into picture. And then, like I said, emails are semi-structured data because you cannot predict the date of some group of mails. Whereas you can predict. You can point out who is sending the mail, to whom they are sending the mail. as only some part of the data is structured. I would say it's an example for semi-structured data. And like I said, audio, video, image files are the examples of unstructured data. Okay, these are the types of data on a whole. Okay. So let's this slide explains an actual facts about the data which we are receiving. Yeah, no props. Yeah. So this particular slide will explain you that it's a self-readable. Let me give a gist of it. See, it's explained that from 1986 through 2007, the estimated data is 295 exabytes. Now the data stored around the world, sorry, it's 295 million or billion gigabytes. That's the fact between 1986 to 2007. After 2007, in 3 years, we had seen the data to be grown to the to 600 exabytes, which is almost like doubled. The data got doubled or something like that. So this is a slide which points you that the data is going very faster. I mean, that's again we had already discussed about that, because every organization is producing huge data, and the production of the data is increasing day by day. Okay, that's what I meant to explain using this slide. It's a self-readable. You can see here the percentage of data that each particular thing is contributing for. The hard disk, which stores the data, are contributing for the 52% of the data, and all other like optical storage devices are 28%, digital tapes are 11%, other forms of storage are holding 9% of data. Okay, this is the actual fact I try to show. Right? And this is something which is satirical, that if you are to take all the information and store it in books, we could cover the entire area of US or China in 13 layers of books. Okay. Now, let's look at the properties of data. Yeah. Okay. For others, the question is like, I had explained about the binary files, audio, video, image files. Everything is a binary file. So when you look at a binary file, you just give it a try actually. If you are having some putty box, you take some image file into your putty box and give a display like cat of that particular image file. Okay, you'll look at some junk values out of it. Yeah, all those will be some junk values. So that's called unstructured, which is in binary format. So as part of your analysis using Hadoop, we cannot do anything on binary format. So what we do is we convert that into sequential format. Okay, we convert the binary format files into sequential format, and then we do analysis on that, and we'll arrive at our solution. Like I explained in my previous case study, like I'll filter out the duplicate images out of some 1 billion images using MapReduce. So in order to filter out, I got to convert the binary format into sequential format. The format is it's sequential format. Okay. So let's look at the properties of data now. Okay. Like I said, the volume. I have quoted an example again, New York Stock Exchange is producing 10 terabytes of data per day, and Google, Facebook is producing 15 terabytes per day, and Twitter is producing almost 7 terabytes per day. That means the volume of data. The volume is one property of data. How the volume is getting increased. That means the core funda for learning Hadoop is the volume. The volume is keep on increasing day by day. Okay, the volume, when I say volume, it's the property of data. And velocity. Velocity is nothing but the speed at which the data is receiving. Let's again go back to any social networking site or any medical organization. Let's start with social networking. When someone had tweeted in Twitter, okay, many people can retweet it, right, and they can like it, right, and they can follow a person. whatever they do, everything is data. For example, let's say you have shared some pic in your FB. You can share it in hardly in seconds. From your mobile, you can upload it and you can share it to the public. Okay, and people do comment that, and people do like that. So everything happens in fraction of seconds. So as I said, even if you like a post in Hadoop, sorry, in Facebook, it contributes about 10 kilobytes of data in Facebook. So look at the speed at which the data is being produced. That's the property of data again, velocity. Okay. And variety. Like I said, there are many varieties of data like structured, semi-structured, unstructured. Okay. That's the variety, and again, that's the property of data. We have called veracity. That's the interesting property again. When talking about big data, it's nothing but analysis of larger data sets. So when you are analyzing larger data sets, then you will be having a lot of chunk values. Let's say some log analysis. You have some IP address. Okay, you wanted to analyze your log of a number of hits that a particular IP address has done or something. So in order to do that, you got to analyze your log file. Okay, in order to analyze your log file, you got to cleanse your log file because there will be a lot of unwanted data. So when you are dealing with a lot of junk values, the accuracy at which you are arriving at your results is nothing but the veracity of data. Okay, 1 second please. Like I said, veracity is nothing but the accuracy at which you are arriving at the results. And why this property is important when it comes to Hadoop is you are dealing with a lot of junk data, right? When you are dealing with a lot of junk data, you will be arriving at unprotected results. So in order to arrive at the predicted results, you got to take care of your logic of your MapReduce or something. But the core here is the main point here is veracity. Veracity is nothing but the accuracy at which you are arriving at the results. Okay, that's what I wanted to mention. Yeah. There are some other things like volatility. Okay, volatility is nothing. There is another property called volatility. Volatility is nothing but the speed at which their data is changing. Because when you take some banking organizations, okay, they'll have some month-end reports being generated, right? So when they have month-end reports generated, at the end of the month, that particular data, they'll be purging the data or whatever it might be. They will be deleting the data or whatever the way they want, they can do it. So after the end of the month, you will be receiving the new data. That means the data which you have received for this month is no longer valid. Only you will be looking at the next month's data. So that's the property of volatility. The speed at which the data is changing is called volatility. Okay. And any questions on this particular slide? Anyone? No one has questions? Okay. You're understanding it too better, or you're not getting anything. I mean, there could be two reasons why people doesn't ask questions. When they understand everything, they don't ask questions. If they are not understanding anything, they will not ask questions. So you might fall into either of the category. I would assume that you are falling into the first category. That's why you are not asking me any questions. Great. I'm moving to the futures of Hadoop. Okay. Okay. I'll talk about veracity. Vijay, I'll come back to your question. Let me answer Nilima's question. Like she has asked to explain core veracity once again. Okay. When we talk about big data, right, we are dealing with huge amount of data, like I said. let's talk about a specific example called log analysis. You wanted to filter out, I mean, you'll have some 10 terabytes or 20 terabytes of log files, out of which you wanted to filter out all IP addresses that are present in an each log. Okay, so you write your Java code. I mean, you'll use some regular expressions, something like that, to filter out your IP address. Okay, because you'll have to have three digits, three digits. Your IP address should look like that. So you'll have your regular expression to match that particular pattern. Okay, you'll write your programming. But when you are dealing with some 10 terabytes of data, okay, and your result is only almost like 1 GB of data, your output will be. But when you compare this 1 GB and 10 terabytes, right, that means there is a lot of junk data involved in your log files which you don't require. So when you are dealing with large amount of junk data, out of which only 1 GB of data which you require is present, that means you might have, I mean, there would be a great probability that your final result may not be predicted. It can be an unpredicted result. So when you look at this picture, you should understand it's the accuracy. Accuracy at which you are arriving at the results is called the property of veracity. Okay. I mean, I'm just relating it with big data because you'll understand it better down the lane as well. When you are dealing with huge data and when you are arriving at a very small result, there should be some proper mechanism that has been taken care to arrive at your result. Because the amount of junk data that is present in your log files is greater than the actual result which you want. So you've got to take a lot of care. You've got to be very accurate. That's what veracity is. Okay. Yeah. Vijay is asking me, like, what is sequential file format and who convert the binary file format to sequential file format. Yeah, I mean, Vijay, don't worry, we'll discuss about this during our case study, but it's we who has to do the binary conversion to sequential file format conversion, and that's again we'll do it using either Java or Python. We can do that. Okay. But I'll definitely explain during our course of, I mean, I'll show the code actually, how to convert the binary format to sequential file format. Yeah. Because it's hard to explain that rather than, yeah, we use Java to convert a binary to sequential file format. Let's talk about something called scalability here. Scalability, there are two types of scalabilities, the properties of scalability, like linearly scalable, non-linearly scalable. So let me quote few examples here. Let's take two vehicles, four-wheelers. One I'll name it as RDBMS and one I'll name it as Hadoop. Okay. So when I have two vehicles naming RDBMS and Hadoop, right? So each is giving 15 kilometers per liter of diesel, both RDBMS and Hadoop. Okay. When I double the configuration of both RDBMS and Hadoop, both the four-wheelers, okay, when I double the exact configuration, like 15, with the horsepower, everything, I'm by doubling it. And then doubling the horsepower and everything, after improving its hardware, my Hadoop four-wheeler is giving me 30 kilometers per liter of diesel, whereas my RDBMS is giving only 20 kilometers or 22 kilometers per liter of diesel. That means when you are adding some resources, Hadoop is giving the result to that extent, whereas RDBMS is not, which shows Hadoop is linearly scalable. When you are adding your result, I mean, when you are adding resources, you can expect the result to that particular extent. Okay, that's what scalability is. Affordability. While explaining about the architecture of Hadoop, you might have asked me a question stating that, hey Surya, you are saying that rather than having one person to lift the brick and put it into another place, you are saying that I will recruit 9 more people and have my work done. That means you are increasing the resources, which in turn increasing the budget, right? But there is a catch here. I told all the nodes that are in Hadoop are made up of commodity hardware. Commodity hardware is the cheapest hardware available in the market, I told you. So when you compare with your enterprise hardware and commodity hardware is 90% cheaper than your enterprise hardware. That's where the Hadoop has got its prominence. It's very cheaper and affordable, okay, and reliable. And again, you can ask me a question like, example of commodity hardware. What I would say. See, you talk. Let me go it this way. Let's take an Apple laptop or Apple desktop, and let's take an assembled desktop. Okay, if there is some issue in your hardware or something, you cannot go to a particular enterprise entrepreneur or the owner of the product because it's the cheapest hardware. It's not like it doesn't have any warranty or anything. Okay, you cannot go to some owner of the product and ask him provide me the services because you are not paying that much. When you are having some Apple desktop, if that has some problem, you can definitely go back to Apple and say that, hey, I got this problem, resolve it, because they'll be providing the services. That's the difference between enterprise hardware and the commodity hardware. Okay, got it, Vijay? Okay. So, like I said, and you can ask me again, hey, how can you rely on commodity hardware? You are saying that it's the cheapest hardware available. How can I rely on this and put my data into this hardware? You can ask me that, right? Do we use Oracle RAC for commodity hardware? No, we don't use Oracle RAC for commodity hardware. Again, Oracle is an enterprise hardware. We don't use that. Okay. The question is, the explanation is the commodity hardware cannot be relied on, right? So how can I invest on this so that how can I depend on this to store my data? That's where the reliability concept of Hadoop comes into picture. Hadoop internal architecture takes care of all the failures of the data nodes because a commodity hardware can fail at any time. So when I have 10 people who are allocated some work, then some person has fallen sick, and Hadoop architecture will bring in another node in place of that particular person who has fallen sick. It has that capability, auto failover. That's why we can rely on Hadoop. Hadoop has reliability which takes care of auto failure. Okay. So your work doesn't get impacted. Flexibility. As I said, you write your MapReduce logic, and I already told you that Hadoop is a framework written in Java, but it's not that you write your MapReduce only in Java. You can write it in Python, you can write it in Perl, you can write it in CPP, you can write it in any programming language available. There is some concept called the streaming, which streams your programming language into Java bytecode. That's where Hadoop flexibility has come into picture. Okay. And finally, Hadoop is distributed, which we already discussed about. Right? Any questions on this particular slide? Or any questions overall on overall session, because I'm done with my session, demo session. If anyone has any questions, I will take up the questions. I appreciate, Vijay, you are asking, what is sequential file? When I say binary file and sequential file, there are two different formats. Okay, binary format is something which is compressed format, and sequential file format is in the manner of some some alphabets and some digits. It will be a combination of all alphabets and digits. That will be a human readable format. Sequential format will be. Binary format will be a group of some junk values. Like just give it a try. Like as I said, you can capture some image file, which will be looking when you display the image file, you will get all the junk values. Like a binary format, for example. example, if you look at a C code, right? And you look at a C code, if you display it, you can a normal C code before compilation. If you look at it, it will be it will be in sequential file format. When you compile it, it will be converted into a binary format, and when you try to display it, you will be displaying, you will be looking at only the jump value sort of it. Okay, that's the best difference I would say between the binary format and sequential file format. Yeah. Okay. So, any more questions? Of course, there are. Oracle is not a Hadoop product, right? There are the rest Hadoop products are. You wanted to ask who are using Hadoop, or which parts of which ecosystem components of Hadoop are in best use. I didn't get your question actually. Mohan, my question is if which components, right? Yeah, there are many ecosystem components of Hadoop that are in best use. Okay, I thought of explaining about that in my next session or something. Okay, there are many components like there is Hive, okay, which will be like a data warehouse. Okay, there is Peak. Again, it's again another ecosystem component which is widely used. HBase is a NoSQL database. I could say again this is very vastly used. Scoop. I will explain about each of its components in the next session. We have something called Flume. Okay, these are widely used. We have something called Hue, again, which is again a ecosystem component of Hadoop. So I would say all these are very vastly used ecosystem components, and HBase and Hive are used by Facebook. Okay, and I would say to get some data from Twitter or something, we would use Flume. And Yahoo is the one who had developed this Pick, and they are the primary users of Pick, and it's a very interesting ecosystem component, I would say, Pick. And Scoop again to get your data from RDBMS. Yeah, all these are widely used ecosystem components of Hadoop. Yeah, did I answer your question, Mohan? Great. Okay. Any more questions, please? Yeah. If you have no questions, then we'll connect back on Tuesday IST at 8 a.m. So yeah, hi Nilima. If you have any questions, please. Yeah, I would say like sandbox. I would be using Cloudera VM image. Okay, I use it using VM workstation, and I'll explain everything. It's totally on CentOS, because CentOS is the one which will be widely used the Hadoop ecosystem component. And again, I show the Hadoop installation on Ubuntu. Okay, I'll show how to install Hadoop. Of course, in CDHC VM image itself, I'll be showing all the mapper views. We code it using Eclipse, and we transfer that particular jar file into local file system, and we execute our mapper views. That's what every practical thing we'll be doing on CentOS and everything. CDHC package. And let me tell you, this particular 35 hours or 30 hour session would be totally, no, it's a pseudo mode cluster. Yes, it's a pseudo mode cluster. and I'll show you the installation of Hadoop on sudo mode as well. Yeah, on Ubuntu. Exactly. Okay. So, only try single mode. Does that mean not exactly using HDFS? We'll be using HDFS. It's not that we'll not be using HDFS. We'll be using HDFS, and we'll look at all the config files and configurations of Hadoop. Everything would be same. But the only thing is we'll be using sudo mode rather than using multi-mode. We are using sudo mode. That's the only difference actually. Of course, we would be using HDFS as well. But everything gets distributed among a single file system. Yes, of course. That's what I'm saying. That right, like a single node will be partitioned across, and a single node will be used as a distributed file system here in a sudo mode. That's the difference between a distributed mode and the sudo mode. In a normal production cluster, yes, you will be having multiple nodes. Yeah. Any more questions, Nilima? See, I would say that it will be HDFS on single node is as good as using a single. No, I would say like, see, the distribution of MapReduce and everything would be same, okay, and all the stuff would be same, but the performance compared to a distributed mode will be different when compared to a sudo mode. I agree that. But when you work on Hadoop, all the things like creating MapReduce or creating some custom scripts on HDFS, everything would be same. Performance wise, yes, I would agree that the distributed mode and the sudo mode differs. Exactly, exactly. Yeah. And mostly I will talk about practical things only, not theoretical things. I'll explain all the things practically, but on a sudo mode. Uh, Project, you mean the projects which I will be explaining? I mean, it's be a different case studies. Like for MapReduce, I will be giving some custom segment analysis to analyze the customer data. Then I'm talking about Flume, I talk about a case study, how to pull the data from social networking sites. Okay, and when I'm talking about Hive or Pig, I'll talk about different UDFs we'll be writing for Hive and Pig. Everything will be a case. At the end of each part, I'll be giving a case study. It would be like something like a mini project actually. So I cannot say a single project will be working. Okay. Yeah, no problems. Okay. Thanks everyone. Thanks for joining the session. Yeah. Hope to see you.